So in this case, I have a formula, and this formula is a formula of the volume of a cylinder, right? So if you look at this, it's a volume of a cylinder, which is equal to pi r squared. How many variables do you see here? Three variables, which are?
Pi r squared and the height.
Pi is not. Pi is 3.4.
Volume,
No.
radius, and
R,
height.
H, and
the volume.
the volume, right? So there's three variables. So you have the volume, you have the radius, and you have the height, right? Now, which one is the dependent variable, and which ones are the independent variables? V is your
Dependent.
dependent. So V depends on the volume of your cylinder, depends on what your radius is and what your height is, right? So volume is your dependent. And then the radius and the height are the independent variables. Now, if you want to, find what your volume is, right? You can just pick a value for your radius, a value for your height, and then you would know what your volume is, right? So my question here is, so to determine the relationship between the dependent variable and one of the independent variable, you're going to set the other independent variable to some constant value. So let's say I want to know what the relation is between the volume and the height. What I would do is I would set the radius to be a certain value. Okay? So let's say I want a cylinder of a radius of 2 centimeters. Right? So I set my radius to 2 centimeters, right? And this way I will know the relationship between the volume and the height. Because at this point, if I set the radius to be 2, the only variables I have is the volume and the height, right? If I want to know what the relationship is between the volume and the radius, I set the height to a constant value. And I say I want the height to be 10 centimeters, okay? So the minute that I set the height to a value, then the only two variables I have are the volume and the radius. Okay? So you're going to have to pick one of your variables, which is usually one of your independent variables, and then independent variables, and then you're going to have to give them a value, one of your independent variables. Once you do that, you're going to rearrange the equation to solve for the other variable. So let's say if I give h a value, right, and I want to know what the relationship is between volume and radius, I isolate for the radius by bringing everything else to the other side. And then you can determine if the relation is, let's rearrange the equation solve for the independent variable instead of calling it the other. And then you're going to determine if the relation is linear, quadratic, or some other nonlinear relation. Let's look at an example. What do I mean by all of this? So if I look at the formula, distance equal to 1/2 the a, which is the acceleration, times the time squared. Okay, so it's half at squared. So that's basically the distance traveled by a car as it accelerates. So a represents acceleration from a stop position where d is the distance traveled in meters, a is the acceleration in meter per second squared, and t is the time elapsed in seconds. So they gave us a formula and they gave us what each letter represents. Are we okay with that so far? Okay. Now it's asking you to investigate the relationship between D and A where T is 2 seconds. So in this case, how many variables do I have in the equation?
3.
I have 3, D, A, and T, right? Now in this question, it's telling me that T is 2. And they want you to investigate the relationship between D and A. So what I have to do here is I plug in the value of T in for T. So instead of T, I'm going to replace that with 2. So that becomes 2 squared is 4. 4 times a half, that's 2. A. So if you look at this, what kind of relation do I have between D and A? Is it linear? Is it quadratic? Or is it something else?
Quadratic.
It's linear.
Oh, linear.
It's linear. Because what's the degree on the independent
1.
variable?
1.
It's 1, right? So this is a degree of 1, so that's a linear function. So it's a linear relationship between distance and acceleration. So if I want to draw distance and acceleration, it's going to be a linear function. This is what it means. Okay? So, the relationship between distance and acceleration is linear.
Is it the over like relationship between all
Between.
Okay.
That's me writing between. That's what it's for. Okay, so investigate the relationship between D and T when A is 2 meters squared. So in this case, they give me that
Acceleration.
the acceleration is 2. So I'm going to replace A with a 2. So 2 times a half is
1.
1. So that's D equals T squared. What kind of relationship do I have
Quadratic.
here? It's a quadratic relationship.
Okay. I see now.
So, as we did yesterday with the linear regression model, we can use quadratic regression model. Regression to model data that appears to lie along parabolic curve and produce an equation of best fit. So, or a curve of best fit. So you're gonna have to look at your data. Okay? And if your data look like they are following a quadratic or a parabolic trend, then you want to use a quadratic regression. Okay? If your data look like they're following a linear trend, you're going to have to use the linear regression model. Okay? So it all depends on how your data looks like. So we're going to do exactly the same thing as we did yesterday. We're going to graph the data given to us. We're going to look at the data, and we are going to decide if it's quadratic or if it's linear, and then we're going to pick the different regression line that we have. So what I have here is I have a fountain of sparks from a Canada Day rockets, follow an arc in the air. This table shows the height of the spark at various horizontal distance from the launching point. So distance from the launching point, so let's say this is your launching point, so how far is it away from the launching point? So it's 5, 10, 15, 20, 25, and 30. And this is the height of the rocket as it goes up, right? So what goes on the x, what goes on the y?
Distance goes on the x
Yep,
and height goes on the y.
that's true. Okay, so what you're going to do, you're going to take this data, you're going to put it in Excel, and then you're going to find a graph of, a scatter plot, and then we're going to talk about how to find the line of best fit, or the curve.